Hello everyone, how are you all? I hope all of you are safe, sound, and doing your studies in full swing. Hold on right from the beginning itself. Don't keep anything for the last moment because well begun is half done. Learn the things, understand the concept, apply the concept whatever you have studied, and practice it because practice, that is the only known method for studying physics or mastering our physics. If you are not practicing it, no coaching classes, no videos, no teachers can help you out. So practice. All right? Okay, now let us come back to our today's topic. Today's topic is total internal reflection in a prism. We have seen in the last sessions how the total internal reflection is taking place. What is total internal reflection, TIR? What are the conditions essential for TIR? What is critical angle, the concept of critical angle? All these concepts are described in our previous videos. If you haven't watched the videos, please watch the videos and learn the concepts. Today, we are going to learn how the total internal reflection is taking place in different types of prism. So when we consider different types of prisms, we have three different types here. First is 45, 90, 45 degree prism. It is also known as total reflecting prism. Right angle total reflecting prism. Total reflecting prism. It is also known as right angled isosceles prism. Such prisms are having 190 degree. One angle is 90 degree and other two angles are 45 degree. Another type of prism is known as prism equilateral glass prism. That is 60 degree prism. It is called equilateral prism or regular prism. Regular prism or equilateral prism. And the third type of prism is called, we have a 30 degree, 90 degree and 60 degree prism. It is called right angled prism. Right angled prism. So these are the three types of prism: 45, 90, 45, total reflecting prism, 60, 60, 60. It is known as regular prism, 30, 90, 60 degree prism. It is called right angled isosceles prism. So let us study how the total internal reflection taking place in case of the first type of prism, that is total reflecting prism. Now let us consider how TIR is taking place through a 45, 90, 45 degree prism. It is also known as total reflecting prism or right angled isosceles prism. As you can see on the diagram, a prism having an angle of 90 degree between its two refracting edges, such that two angles are 45 and 45, one angle is 90 degree. Such type of prism we call it as 45, 90, 45 prism or total reflecting prism. In this case of prism, light rays can incident normally on any of the surfaces and can undergo total internal reflection. As a result, this prism is used in three different ways. This prism has got three different purposes. So first case, deviation through 90 degree. So this prism is used to deviate a ray of light through 90 degree. So we are learning how the deviation is taking place through 90 degree. Alright? Okay. Now let us consider the face AB. A ray of light is incidenting normally on the surface AB, and as you know, it passes undeviated for normal incidence and striking the surface AC. Okay. So you draw a normal to the point of incidence. We don't know the angle of incidence here. What is this angle of incidence? How much it is? Just apply the basic concept of knowledge of geometry. So this angle obviously 90 degree. This is 45. So this angle must be 45 because some of the angles of some angle in a triangle is 180 degree. You know it. So if it is 45, for normal, how much this angle of incidence? This angle of incidence also will be 45. So the angle of incidence is 45. So which is greater than critical angle for glass air interface. For glass air interface, what is the critical angle for glass air interface? It is 42. So since angle of incidence is greater than, I can write since angle of incidence is greater than the critical angle, that's equal to 45 degree. What will happen? Instead of getting refracted out, it will get turned, it will get totally internally reflected through an angle. How much? Angle of reflection must be equal, again 45, and it is traveling through the glass, striking the surface BC normally and passes undeviated. So how much degree the light ray has turned here? 45 plus 45, that angle of turning is 90 degree. All right, so we can draw one more ray here, passes undeviated, striking the surface here AC, again it is getting further turned through 90 degree. So here angle 45, this angle also 45, the 45 plus 45, total 90 degree. So the light ray has turned through 90 degree on passing through total reflecting prism. So the ray diagram is important, marking leveling of the angle is very important. Okay, so this action of prism is used in periscope. So remember that this action of prism is used in periscope. So use, very important, used in periscope, where total reflecting prism is preferred over a plane mirror. If you keep a plane mirror, what will happen? So plane mirror also will do the same purpose of that of a total reflecting prism, but there is loss of energy and the image will be slightly, or it will be less brighter. Here total inner reflection is taking place, there is no loss of energy, and the light ray is getting turned through 90 degree, as you can see 90 degree turning here, and it is used in periscope. Clear? Fine. Let's study the second case, how total reflecting prism is deviating a ray of light through 180 degree. So in the first case, a total reflecting prism is kept like this, I said BC is the base. Here in the second case, just we can notice that just the orientation of the prism is changed. So AC is the base on which the prism is resting. The initial case BC was the base. Okay, so just in the second case, in deviation of ray of light through 180 degree, just the orientation of the prism has changed. So let us see how it is turning a ray of light through 180 degree. A ray of light, consider an object PQ here. A ray of light originating from Q, striking the surface AC normally, passes undeviated and striking the surface AB. What is the angle of incidence here? Draw a normal. This is 90 degree. This angle obviously 45 degree. So if it is 45 degree, the angle of incidence must be 45 degree. You can see this angle of incidence is 45 degree. So the angle of incidence is 45 degree. So I can say that angle of incidence is greater than the critical angle for glass air interface, that is 42 degree. So as a result, what will happen? It will suffer total internal reflection, and it is again turning through an angle of reflection, that is 45 degree, since angle of incidence is equal to angle of reflection. Alright, and this reflected ray traveling through the glass prism, striking the face at BC at an angle. What is the angle of incidence? Again draw a normal. Okay, so what is this angle of incidence? This angle will be 45, this angle also will be 45, of course 45. This angle of incidence again 45 degree. Since angle of incidence is 45 degree, which is greater than for the critical angle, again it will totally internally reflect and striking the surface AC normally, passes undeviated, it will emerge out. So what is the angle of reflection? Here being 45 degree. Alright, so angle of incidence is equal to angle of reflection. So what is the total angle through which light ray has turned? Here it is 90, you can see here it is 90, here it is 90. So 90 plus 90 is equal to 180 degree turning. Alright, okay, so you can see that the light ray has turned through total an angle of 180 degree. So from here also we can, a ray of light can travel passing undeviated striking surface an angle of incidence 45 degree, and again turning through an angle 45 degree. Alright, striking the surface BC at an angle of incidence 45 degree, and again, since angle of incidence is greater than the critical angle, again it will turn through an angle of reflection, that is 45 degree. Striking the surface, it will emerge out normally. Alright, so this will be, see how the object is appearing here. This is Q, this will be Q dash, and this is P dash. Alright, so you can see that this prism has turned the light rays through an angle of 180 degree here. It suffers total internal reflection at AB and BC with an angle of 90 degree and 90 degree, total 180 degree. Alright, so this action of the prism is used in binocular. So the use of this prism is used in binocular and camera. Very important, remember the use of this prism. It is very important for the board examination. So this action of the prism is used in a binocular and camera to invert the image without the loss of intensity. So you can see that the image has inverted. Okay, so the PQ, now it is P dash, Q dash. As you can see clearly on the board, this prism has inverted the image without any loss of intensity. We are getting a very clear, brighter image as there is no loss of energy here. So this is the action of a total reflecting prism to deviate a ray of light through 180 degree. The ray diagrams are very important. When you make the ray diagram, mark the angles very clearly and the direction of ray of light. And remember the use also. Use it binocular and camera. Alright? Okay. Now the third use of total reflecting prism is to erect an inverted image without any deviation. In case of slide projectors, we have to erect an inverted image without any deviation. In that case, we take the help of total reflecting prism. Let us see how total reflecting prism serves to erect an inverted image without any deviation in case of slide projector. For that, let us consider an inverted image, PQ. PQ is the inverted image. A ray of light traveling from the point P strike the surface AB, and it is getting refracted through the prism, striking the surface AC at an angle of incidence greater than the critical angle. So it suffers total internal reflection at the surface AC. And since here at the surface BC, the angle of incidence is lesser than the critical angle, it refracts out, deviates away from the normal. Okay. Now, from the point a ray of light, another ray of light travels and strikes the surface AB and suffers refraction and passes through the prism and strikes the surface AC at an angle of incidence greater than the critical angle, and as a result it will suffer total internal reflection. It is getting total internally reflected back and strike the surface BC at an angle of incidence less than the critical angle, and it will suffer refraction in place of TIR. The total internal reflection is taking place only at the surface AC. At surface AB and BC, light rays are getting refracted. So since it is traveling from denser medium to rarer medium, bends away from the normal. Alright, and you can see that the image, this is C, the follow P, this is the image P here, and this is, I can write P dash Q dash. Alright, so this is P and this is for Q, P dash Q dash. You can see that an inverted image is being erected without any deviation. See, there is no deviation. You can see there is no deviation. It has not changed its position. So on passing through a total reflecting prism, light rays are turned through total 90 degree and an inverted image has erected. Alright. Okay, so this is the action of a total reflecting prism, and this action of the prism is used in slide projector. Where it is used? In slide projector. Slide projector to erect an inverted image without any deviation. Ray diagram is very important. Practice the ray diagrams. So remember that only TIR is taking place at the surface AC, and at surface AB and BC only the plane refraction is taking place, such that light rays has turned through 90 degree. Alright, fine. We have seen the action of a right angled isosceles prism and its different uses, 3 uses, and how the TIR is taking place through a right angled isosceles prism. Now in the second case, we will study the action of a regular prism. What is a regular prism or equilateral glass prism? So a regular prism having all the 3 angles 60 degree each, 60, 60, 60. You can see all the 3 angles of a prism are 60 degree. Such a type of prism we call it as regular prism or equilateral glass prism. Let us see how the total internal reflection is taking place through a regular prism and through how much angle the light ray is getting turned. For that, let us consider an incident ray striking the surface AB normally. So for normal incidence it passes undeviated, you know it, and it strikes the surface AC. At what angle of incidence? We don't know the angle of incidence. To find out the angle of incidence, just draw a normal to the point of incidence and apply the basic knowledge of your geometry. So what is this angle? How much this angle? This angle will be 90 degree. 90 plus 60, total 150, and the remaining angle, as you know, it should be 30 degree. Alright. So this is a normal. If it is 30 degree, this angle must be 90 minus 30. It should be 60 degree. So the angle of incidence is 60 degree. So the angle of incidence is 60 degree, which is greater than the critical angle for glass air interface. So when the angle of incidence is greater than the critical angle, what will happen? The ray of light will get totally internally reflect. It will suffer total internal reflection at the surface AC. And what is the angle of reflection? Through how much degree it turn? Since angle of incidence must be equal to angle of reflection, it must turn through 60 degree. So light ray is getting turned through 60 degree and striking the surface BC normally, and passes for normal incidence, it passes undeviated. So you can see light ray suffers TIR, total internal reflection, at the surface AC, and it is getting turned through an angle 60 degree. So a regular prism turns or deviate a ray of light through 60 degree. So this is the case of deviation through 60 degree. So light ray is getting turned through 60 degree. Alright. So this is the action of regular prism or equilateral glass prism. Alright. The ray diagram is important. Study the action of a right angled prism. What is a right angled prism? A right angled prism is a prism in which one angle is 90 degree, other 2 angles are 60 degree and 30 degree each. Such a type of prism we call it as right angled prism. So this right angled prism can be used to deviate a ray of light through an angle less than 60 degree. Now let us study the deviation of light ray through less than 60 degree. How it turns a ray of light through less than 60 degree. For that, let us consider a ray of light. This is a right angled prism A, B, C, and a ray of light is incidenting the surface BC normally, and it passes undeviated for normal incidence, striking the surface at AC at an angle of incidence. What is the angle of incidence? This will be 90 degree, this angle 60, this remaining angle is 30 degree. This, of course, this angle for normal incidence, this angle will be 90 minus 30, that is 60 degree. So angle of incidence is 60 degree. Angle of incidence is 60 degree, which is greater than the critical angle. So a ray of light is getting totally internally reflected through an angle of 60 degree. So the angle of reflection is further 60 degree and is getting turned through 60 degree, striking the surface AB at an angle, draw a normal, an angle about 30 degree. So this is 30 degree. So this angle of incidence at the surface AB is 30 degree, which is lesser than the critical angle, and as a result, in place of TIR, it will refract out, it will emerge out, deviate away from its normal, as the ray of light is traveling from denser medium to rarer medium. And you can see that P, Q R. PQ is the incident ray, QR is the again refracted ray, RS again it is RS ray is suffering total internal reflection at the surface AC and striking the surface AB. RST, ST is the emergent ray. So the emergent ray, you can see that the emergent ray is getting turned through an angle delta, which is less than 60 degree if you compare the angle delta with the incident ray PQ. Alright, so this is the action of right angled prism, which is used to deviate a ray of light through an angle which is less than 60 degree. Alright, so this diagram is very important. Okay, fine. Now let's consider the case of a right angled prism, a special case of a right angled prism in which there is no TIR is taking place, non-occurrence of TIR. Let us check out how there is no TIR is taking place. For example, the case number 1, a ray of light PQ is incidenting on the surface AB. Okay, normally, so for normal incident it passes undeviated and strikes the surface AC. So what is the angle of incidence here? We don't know. So we have to find out. This is 90 degree. So 90 plus 30, 120. The remaining angle 180 minus 120, it is 60 degree. Okay. So for 60 degree, so this is the normal. So 90 minus 60, the remaining angle is 30 degree. So the angle of incidence is 30 degree, which is less than the critical angle. When the angle of incidence is less than the critical angle, what will happen? What will happen? It will not suffer any total internal reflection at the surface AC, and in place of TIR it will suffer refraction. Alright, it will suffer refraction at the surface AC and it will go away as it passes from denser medium to rarer medium, it will deviate away from the normal. So you can see that there is no TIR taking place when the ray of light is incidenting at the surface AB normally. Now let us check out in case number 2, when the ray of light is incidenting normally at the hypotenuse AC. At the hypotenuse AC, a ray of light PQ is incidenting normally, it passes undeviated, striking the surface AB at an angle of incidence. We don't know the angle of incidence. This will be, of course, 90 degree. This will be 30, and this is 90, 30, and this will be 60 degree. So the remaining angle is 90 minus 30, that is 60. 90 minus 60, that is 30 degree. So the angle of incidence here also is 30 degree, which is less than the critical angle for the glass air interface, and as a result what will happen? It will in place of total internal reflection, so it will not suffer any total internal reflection here at the surface AB. It will suffer refraction and it will deviate away from the it will deviate away from the normal. Alright, since it is emerging from denser medium to rarer medium, and you can see that there is no total internal reflection taking place in both of these cases. Alright, this is a special case of a right angled prism for non-occurrence of TIR. So remember these two cases, very important. Alright, okay, thank you very much. That's all for today.